Alright, so I'm going to be talking about my implementation of the behavior tree for the first mandatory assignment. And I'm first going to be looking a bit at the Pacman code just to see the baseline, and then I'm going to go into the behavior tree itself. So I made a few changes to the base Pacman, which I will go through here. So the first one is that I simply created this function which gives Pacman access to the ghosts and the pellets and the nodes, since we need those for the algorithm. And other than that, I simply changed a few things in the update function. So here we can see that the direction is being determined by the direction method, and this direction method is being determined by this behavior tree here, as we will see later. But those are the only main changes to the update function. So I created two states for the Pacman, as this seemed the easiest way to complete the task. So I created a task where it simply wanders and tries to find pellets, and then I created another state where it's fleeing the closest ghost. So if we look at the one where it's wandering, it's called wander biased. And first we find the closest pellet in Manhattan distance. So I wanted to do this actually with Dijkstra's, which I think would have made a lot more sense, especially for further pellets, but I couldn't make it work. Maybe I will look at it later. And then, so we find the closest pellet, and then we simply look at, so for our current target, which way should we go in order to get closer to this pellet, and we do that by adding together our own vector location with some viable direction that we can go, and then we subtract the closest pellet position from that, and the result then we will simply take the smallest number we can get there, and then take that direction. So these things are put into a dictionary and an array, and then we sort the array, and we simply take the smallest, which will be the first entrance, and we return that the direction that gave us this number. So the other one is the simple flee function, which is the one that makes us flee, and it's kind of similar in the sense that it finds the closest ghost, and then so we go through the ghost, find the closest one, and update this variable to contain that ghost, and then we first check whether we are at a node or we're between nodes. If we're between nodes, we simply want to go one of two ways, and we're going to go the way that the ghost is further away from. And there's a bit of fiddling here, because if we're in the same lane as, or between the same two nodes as the ghost, then we don't want to go away from the ghost target, because we'll go right into its arms. So we'll have to make a bit of fiddling there, which I won't go into details with. But yeah, if we're not at a cross, if we're at a cross section, then we will look at the different directions we can go and just take the one where the ghost is furthest away from. So these are two simple versions which sort of make the whole thing work. And then I have the behavior tree here. So I created the base structure. It's very simple. I just wanted to show that that I knew how it worked. So we create the task object, then we have the selector task and the sequence task, which inherit from this. Select the task running until one task returns true, and the other one doing the opposite. Sequence running until one returns false, or if they've all returned true. And then I created two action tasks, one which sets the current state to wander, and another one which sets it to flee. Very basic, but yeah. And then one condition task, which is the checks whether the closest ghost is far away, or if it's actually close, so we need to worry about it. So, and these are implemented here, right here, where first we create the condition action, condition task, and the wander action, flee action. Then we first put the enemy far condition and the wander into a sequence. So we check, is there a ghost close? Okay, if there is, we wander, and if there is not a reverse. So is there a ghost close? No, so we wander, and if yes, then we have that first sequence put into a selector so that if it's false, we go on to the next one, which is flee, and we'll start fleeing.